Hey y'all, it's Calder with 7447G, and I'd like to do an explanation for our Overclock Lady Brown. So back in November, we had a hook robot, One Excellence, decided to do something more fun. We didn't want to do hooks anymore. So we came up with this design. So basically what it is it's just your simple overclock, right? But it can flip, and so it flips and scores rings, and we can also use our Lady Brown to score on neutral stakes. So I just kind of get started. Here we've got the drivetrain. So here, pretty basic 6-motor drive, 450, 2.75 inch wheels. Got Odon pods, so vertical, horizontal. This horizontal one isn't great. Don't use 2-inch wheels. We have a lot of drift with them, so it's thrown off a couple autos. So yeah, we only use 3 wheels. Weight reduction, and we also needed to get this cross brace in, and it would have been a lot more difficult to get this cross brace in and also have good spacing still. If we put another wheel here, we can move on to the gold clamp. So back here we have spikes that just come down passively, so move it back, they fall down, pretty simple. Then we have our gold clamp, so pretty simple again, just ace clamp. Had to get the spacing right, which was a big pain. So pretty simple gold clamp, holds it pretty rigid. It's really good at stealing goals, and it's really good at preventing goals from getting stolen. Because if you look at that, it's holding this goal. The tip of this goal is 4 or 5 inches off the ground. Probably at 3 to 4. About 3 to 4 inches off the ground. So there's a lot there. It's not really good at aligning, but it can grab on points and flat sides, and it doesn't make a difference. We have a doinker. It's a little bit loose right now, but goes down, comes across, uses anti-skid because we have no more bumpers. So really simple doinker, works great for goal rush. Can move on to the intake now. So for our intake, we had to get really special with it. So since the rings have to go so vertical to go up into the robot, we couldn't use ramps because the rings were literally jamming against the ramp. We had to go basically straight up and down, like almost vertical. So we use counter rollers instead. So we have 2 sets of counter rollers and 2 sets of flex wheels. So the flex wheels up here are spinning 400 RPM, and it's all run off of this 5.5 watt. So ring just goes in and goes up. Counter rollers on the bottom are spinning at 1066 RPM, but they all have the same linear speed, so it's the same in the way it affects the ring. So that took us a while to figure out. We went through a lot. At first it was, we had it at like 800, and that was just spinning too slow. It was causing a lot of issues with jamming and getting stuck, but I mean now it's pretty rapid. So yeah, I mean just simple 5.5 watt motor. We have a chain tensioner that works really well. Yeah, so then we can move on to the flipper again. So what we've got is just a simple 1 motor flipper. So here, what it does is just the motor. We have it on a 3 to 4 ratio. It's a 100 cart, so 100 out of the motor, 3 to 4 after that. So it's a pretty simple design. It's really just these C channels and then some Lexan thrown on it. And this Lexan kind of cradles to the shape of the ring, so this ring doesn't really fall out. It's just kind of here. And then down in here at the bottom, we have a limit switch that this goes and hits. It's really hard to see. There's that. So we have the 2 rings load in like so. There you go, they score. We were having a lot of issues and never really did solve the issues of the ring indexing, because teams you'll see with the flipper design like Overclock, their rings will sit in the basket more at like an angle, and ours sitting there almost flat. ours have to sit in there flat because of the Lady Brown. So we really had to fight with it a lot to be flowed properly. And as you can see, I mean, it messes up a lot, and that was pretty much our biggest issue at States. But scores just fine once the rings are loaded in properly. So, then grab, score, really simple. A flaw with the Lady Brown, which was just kind of unfortunate, but some hook bots have it too, is the Lady Brown won't work if there's more than 5 rings on the goal. So simple passive hang, really easy. Velcro plates, Jackson did great with them. Stay on. So they're really light. Our original mag plates were almost half a pound combined. These are about an 1/8, give or take. Hang works really, really well. Just going up. We have a goal right now. And goal, hang, all the way off the ground, even the Odon pods. So, moving on. So with the Lady Brown, we had only 5.5 watt to work with. So we're running it at 50 RPM. So it's not incredibly fast, but it barely has enough torque to like hold and pick up the ring. So, kind of how it works, right? So we've got a ring into the flipper, the basket. So we have it sitting in the robot, right? So we lift up this arm, and then the flipper will flip that ring, will move it from the down position up all the way into the basket. So just hit the button with the macro, and it loads it. So this allows us something that teams like Overclock have to do when they go to score on neutral stakes, is they have to drop their goal. So they'll drop their goal, whatever, it could be stolen, and then they go to the neutral stake and score on it. They can put 1 or 2. So we can only put 1 at a time, so it's a little bit slower scoring wise, but we don't have to drop our goal. So we can go play neutral stakes, never have to drop a goal. We can play it, hold it the whole match. It's pretty great. So this was really, really hard to tune code wise. Took a long time, went through multiple controllers, like method wise. So I think we finally just ended up using a PID. We try to bang, try to PF loop, try to all sorts of stuff, and none of it really just worked that well. Another flaw with this is you have to be right on the neutral stick with it to score. So I mean, you have to like go up and press against it and make sure you're aligned, and then go on up, and it'll do it. If you don't, it doesn't work very well and it misses. And sometimes even when you are, the flex out of the wall stake will make it enough so that this really only goes and just hits it, so you can hold it on, or it just kind of sits on there propped up and it doesn't score all the way. So it's really difficult to get it to properly work, and that's why we'll be moving on from it. It's just, it's not competitive enough. Driving up with it, and then we can score. And here you can see it goes on most of the way. Sometimes if it doesn't grab it right, it'll just prop up like this, and then sometimes it won't even go on, it'll just fall off. But something really neat about this design is it still can score at a similar speed to hooks with Lady Brown. So you can go and load, and then this isn't tuned after states, something damaged in the car. But we can hold a second ring down here. So what we can do, we can score that one, and then we can load a second one, and then score it again immediately. With the Lady Brown specifically, that a lot of hook bots will have problems with, of course, is our Lady Brown can't expand out the front. So this, it doesn't go out the front. Nothing passes right here. So since we expand out the back with the flipper, like this, so this can go out the back, and this button we use to like untip goals. If there's a tipped goal, but since we can't expand out the front, we had to set a hard stop. So right here it's hitting these 2 little spacers, hard stop. which is something that took a long time to tune to make sure we got it just exact, because I mean it's almost exactly the same distance as this out. We had this zip tie right here for a long time. That was the furthest point out on the robot because we didn't have the aligner. It's only 27 wide robot. It is exactly 18 inches long though. We have a ton of sensors on this robot used for programming. If Jackson was here, he could get into it a lot more than I can. So to start with, of course, we've got the Odon pods. I just shut those off. Right, so Odon pods, rotation sensor. We have an inertial sensor just for turns. Lumilib uses inertial sensors. So we've got that right up in here. We have a distance sensor on both the goal clamp. Back here it's really sketchily mounted. So right here on the goal clamp, that's an upside down distance sensor. During auto, if a goal is up in there, it can see it and we can tell it to clamp. So Jackson uses a bunch of fun and cool things with that. So basically we can just tell it to drive in a line until it sees a goal, and then it can grab it and stop and go to a point. And we can also do something similar with our distance sensor up here in the intake, if y'all can see that right here. So it's angled down, so it gives different distances based off of where rings are. But yeah, the distance sensor can basically tell us, we can say spin the intake until there's 1 ring in there, or spin the intake until there's 2 rings. And then if there's 2 rings, it will never go. Also, a problem that a lot of overclocks had is they would get rings under the flipper itself. So we made it so that if the limit switch for the flipper is not being pressed, the intake cannot spin. So right now, intake can spin, right? So intake is able to spin. You can see intake spinning, right? But if we put this out, and it's not being pressed, the intake will not spin. So it won't spin until it's back to being pressed, and then it spins again. So that's a fail-safe that made it so that we never got a ring under the basket. With this code implemented and everything working properly, never got a ring under the basket. The flipper out here can be used to tip goals and untip goals, so that's something real nice. The motor on it moves a lot because all the force it's taken, the screws are tight, just all the force it's taken, it can literally wiggle in the metal. It's drilled out the aluminum a little bit, so I'd be careful with that if you're building this.